So today we're going to talk about the Drake equation. The Drake equation is shown right here, and it is basically a bunch of different variables. It's comprised of about 7 or 8 variables, and each variable has a meaning. So this is the variable, and that is n equals r times f sub n, p times n sub e times f sub l times f sub I times f sub c times l. So it is very long. Okay, so this is a little background on the history of the equation. This is Mr. Frank Drake. He was born in 1930, and he is an American astrophysicist and astronomer. He has greatly contributed to, just what we know about the universe. These are some of his accomplishments. So Drake spearheaded the conversion of the Arecibo Observatory. He's a member of the National Academy of Sciences, and he was elected to the American Academy of Arts and Sciences in 1974. So in 1960, Drake began to start on basically the Drake equation. He began the official search for life in our Milky Way, and this project was called the Project Ozma. So the first one we're going to talk about is variable r. Now, variable r is the rate at which suitable stars are born. This picture represents this idea by showing several stars that could be good for life. And the next variable we have is f sub p. So as you can see, now we have some planets, some moons, and that is a step up from what we just had over here at R, where all we did was have the stars. So this is basically the amount of suitable stars as well as planetary systems. So that includes a set of gravitally bound objects in and out of orbit. Our next variable is n sub e. This stands for the number of planets in a solar system that actually have an environment that can support life. A lot of planets are uninhabitable, from being either too cold or too hot. So you see some air, we have some water, some sunshine. So all in all, this looks like it could have life, maybe it won't, but that is what that variable stands for. Our next variable is f sub l, and that's the amount or the fraction of planets that have actual life on it. So that might mean it has some creatures, it has some vegetation, or even cracks from the ground, like seen on Mars. So these are f sub l is basically the signs that the planet may or may not have some life to it, which is basically a step up from our last variable. Next variable is f sub I. F sub I is the fraction of those planets with signs of life, stars, and everything prior that develops intelligence. So as you see, this looks like an alien, and he has developed at least a language. Looks like he's saying something. So that is what f sub I is, and that's what that variable stands for. Our next variable is f sub c, and that's right next to here. And that is the rate and when those intelligent living species begin to develop communication. So that's F sub C. And lastly, this is L. The last variable is L, and that's the mean length or time that different civilizations can communicate. So yeah, that is the formula used to find the probability of life aside us humans in the Milky Way. Of course, the formula is based on hypotheticals, which leaves a lot of room to guess. And I think that's what Mr. Frank Drake, set that equation up like that for, because there's a lot of room to, interpret what can go there, or what is considered, what can go in those variables. So that is the formula. Thank you very much. Hope you learned something today. I'm Kamar Osman. Enjoy your night.